Good morning everyone. Now today in our class of electronics, I want us to look at the DIAC. Now DIAC has its symbol here. It has its symbol here. We're saying DIAC is the short form of diode for alternating current. Now diode for alternating current, its short form becomes DIAC. So we're saying it is a bidirectional uncontrolled switch. We call it bidirectional. We shall find the reason as we move forward. And then we're saying it is uncontrolled. It is not controlled. Like this switch is not controlled. It is bidirectional and it is not controlled. So it has two terminals, as you can see here. It has the main terminal 1 and the main terminal 2. It has only two terminals. So it has two terminals. Its terminals are named main terminal 1 and main terminal 2, as you can see them in the diagram of the MT1 and MT2, main terminal 1 and main terminal 2. So we're saying there is no control input. Here we don't have control input. That's why we've said here it is an uncontrolled switch. We don't control it because we don't have a gate like in the SCR. We don't have a gate here. So this one is not controlled. It doesn't have a control input. So it switches on for both directions of current flow. It is switching on for both directions. Current can move from this side towards this side, as well as it can move from this side towards the other side. That's why we are calling it a bidirectional. It has two directions. From whichever terminal to whichever terminal, current can flow. That's why we are calling it bidirectional, and we call it uncontrolled because we don't have the gate here. So we're saying it switches on when the applied voltage exceeds breakover voltage. Take note of this. It switches on when the applied voltage exceeds breakover voltage. Here, it cannot block higher voltages in either direction. So in either of these directions, whether from main terminal 1 or from main terminal 2, it cannot block higher voltages. Another point, it only stops conduction when the voltage becomes very low, far below breakover voltage, or when the current falls below the holding current limit. Now the other point is it has a symmetrical structure. Now when we call a symmetrical structure, we mean it is identical from the two sides. Like you can see, this side has a 1 SCR and this side has a 1 SCR. So it is symmetrical, it is identical. Now it has symmetrical firing for both halves of the AC wave, or the current flowing in both directions. Thus there is no harmonics are produced. No harmonics are produced because we are saying the firing here is symmetrical in whichever side. Now it has very low power ratings. Its power ratings are low. And then we are saying it is mostly used for triggering the DIAC. So one of the applications of the DIAC is here given. It is used for triggering the DIAC, and it is used for that purpose because of its symmetrical response. So that is all about the DIAC, guys. In the next class, we shall look at its characteristics and its applications. So do not forget to subscribe to this YouTube channel, comment and like in this video, so that whenever time I upload some other videos, you'll be the first person to see them. Thank you very much.